Alright, squaring binomials. Let's square some binomials. Just quickly, if you guys don't know what a binomial is, it's something that looks like ax plus or minus a b. So it's two terms, one of them has a variable, and they're separated by a sum or difference. That's a binomial. Just quickly, some examples. 7t minus 6, that's a binomial. The variable doesn't have to be an x, it can be anything. In fact, we can make it a smiley face, and we'll make it add 115. 8 smiley face plus 115, that's a binomial. What is more interesting and what this video is about is the little 2 here. So the squaring part of the binomials. The squaring part of the squaring binomial, sorry. So what do we mean when we say squared, something squared? It's anything multiplied by itself exactly once. You take a thing and then you multiply it by itself. And we denote that by a little 2 above, a little 2, that's important. So 2 squared would be 2 times 2, that's 4. If I gave you guys 6 times 6, you guys would be like, whoa, it's something multiplied by itself exactly once. So we could write that as 6 with a little 2 above it, that's 6 squared. And everybody knows that 6 times 6 is 36. And in general, I'm going to write, if you have a thing, a, and you square it, it's equal to a times a. Well, how does that work on binomials, right? Because binomials have this crazy form where they have a plus or a minus in between them, and you're squaring it, and you're doing all kinds of wacky stuff. So I'm going to talk about that next. The first thing I want to say is you definitely don't want to do this, so don't do this. So you have some ax plus b, some binomial, you're going along and you're asked to square a binomial. A lot of you guys want to just do this where you bring down the 2. Please don't do that. That is not what you want to do, right? And that's easy to see because what's really going on when you're squaring things is you're writing it again, right? That's what squared means. You can already see there's something a little more complicated going on than just distributing the 2 down. So please don't do that. If you learn one thing from this video, it's to not do that. Let's do what we should do, and let's go back to our question. So our question was essentially that we're asked to square this binomial. The first thing I want you guys to do is use your definition and write the binomial twice. All I've done is take what's on the inside and multiply it by itself. Well, it's not really clear what to do from here, right? Because it's not clear. But what we can do is use something that we've used before. If I gave you guys 7 times x plus 3, where the 7's on the outside, and I asked you to simplify, you guys would be like, oh, well, I know about the distributive property. I'd just do this, where I distribute the 2 across, right? That's a property we have in math. Well, 7x plus 3, the 7 just distributed, right? And maybe the 7x plus 3 could distribute somehow. Well, it turns out it can, because 7x plus 3 is just an object. So what I'm going to do is distribute it just like I did with the 7 up here. And you guys know about this, I'm just applying it to a little bit more of an abstract concept. So we get 7x plus 3, boom. We got that times 7x, and then I want to do that times 3 again. So I've just distributed, and then I want to do that a second time distributing, so 7x times 7x. Just using the distributive laws all day, every day. Alright, so then that's 3 times 7x, and then 3 times 3, which is 3 squared, so that's topical. Well, what do we have here? A lot of you guys right off the bat would have wanted to use foil on this, right? If I gave you something like this. It turns out that I've just kind of given you foil, like we've just done foiling ourselves without using the acronym. So foiling is first, boom, boom, outside, bam, inside, zam, and then last is 3 times 3. So foiling is really just using the distributive law twice. I can clean this up a little bit with 49x squared And then 3 times 7 is 21, and we're doing that twice. So I can just multiply that by 2. Well, I'm actually adding them together, but it's the same thing, you know. It's all good. So 3 times 3 is 9. And that's our final answer. That's what we worked it out to be. So let's see if that's one of the answers. And as you guys probably guessed, it is going to be one of these answers that they gave us. So it's B, right? So we got this answer. Just to reiterate, it's definitely not these, because the way they got these is by just applying a little 2 down. And we don't want to do that. Please don't do that. So that's squaring binomials. I'm going to do another example really quickly just to, I don't know. Examples are always good, the more the better. Hopefully it helps. So let's see, 6t minus 4 squared. First thing I want to do, use my rule. I want to expand, make things a little more clear. Well, then I can distribute to the 6t, and then, well, here's something interesting. I'm going to do 6t minus 4 times minus 4, right? Because that's this times that. The minus 4 could be brought over here. And then this would be a minus 4 times 6t minus 4. It's equivalent. I could rewrite it, but I'm not going to. Instead, what I'm going to do is keep pushing on. I got 36t, 6 times 6, and then 6 times negative 4 is negative 24t. Negative 4 times 6 is negative 24t, and then negative 4 times negative 4. That's negative 4 squared, and that is 16. And then you just add the middle two terms, negative 48t plus 16. And that's our final answer. So hopefully you guys know how to square binomials now, or at least have a better idea. You can use foiling, but please understand where foiling is coming from and what you're doing when you use it. So, happy mathing, guys. I gotta come up with a better ending. Better sign out.